and we're going to present about basic overview of pulp and paper manufacturing process. But before I start, I'm going to introduce our group. So our group consists of Olivia Putri Salsabila, Faiza Asnazifa, and Baishanas Ramadinipe. So in today's presentation, we're going to discuss about raw material preparation, pulping, pulp washing, pulp screening, cleaning and fractionation, bleaching, chemical recovery, and stock preparation and paper making.
Raw material preparations. Pulp manufacturers start with raw material preparation, which includes the barking, chipping, screening, handling, and storage. A series of operations is needed to convert the logs for pulping. Logs are first transported to the slasher, where they are cut to the desired size. A consistent chip size is required for operations to work properly. The chips are sent in a series of operating screens to remove any that are too big or too small, and the chips and the bark are the two main byproducts of the barking process. Bark is commonly used as a fuel in energy production burners, and there are several the barking procedures available, including ring and flay debarking. After the logs have been debarked, they are chipped in order to minimize the log size and produce chips, thus consuming less raw material. The following step is to screen the created chips to separate large-sized chips that haven't been properly chipped, and the chips produced then can be sent to the pulping process. Conveyors such as chains or roller conveyor are used to transfer chips, and storage facilities may be needed for both raw material, wood, and finished chips. Then, for your next step is pulping. Wood chips are separated into individual cellulose fibers by separating the lignin from the woods during the pulping process. So there are six types of the main pulping process. So the first is chemical pulping, mechanical pulping, and semi-chemical pulping. Chemical pulping is used to extract pulp fibers. It involves cooking raw materials like wood chips with aqueous chemical solutions and high temperature and pressure. The craft and sulfate process are used to heat the raw material into chemical pulps. In chemical pulping, there is craft pulping process involved. The craft process provides pulp for picking as well as high-strength sheets and board. To digest the woods, it uses an alkaline boiling fluids including sodium hydroxide and sodium sulfide. In a reaction vessel, the cooking liquor is mixed with the wood chips, and after the wood chips have been cooked, the digester's contents are pumped under the pressure into a blow tank where they are decomposed into pulp, and more original lignin is preserved in this method. And also sulfate process, the cooking liquid is an acidic combination of sulfuric acid and bisulfite ion. The lignin linkage between wood fibers and are degraded by the acid solution in the cooking liquor, and it is influenced by the type of wood used and the presence or absence of bark. And the advantages is it yields bright pulp that is simple to bleach to full brightness, and also its limitation is it is intolerant to resinous softwoods containing rich hardwood and furnish containing bark. Mechanical pulping. Thermomechanical pulping is used as a refiner, involves high temperature steaming before refining, which softens the interfiber lignin and causes partial removal of the other layers of the fibers. And limitation of TMP is its high specific energy consumption, thus a higher energy demand than ground wood process, and the increase the use of recovered fiber will put pressure on the growth in mechanical pulp volumes. Here we can see the difference in types of pulp. Groundwood pulp, light scattering pulps, which allows low grammages during paper production, offer the possibility of using hardwood to achieve higher levels of brightness and smoothness. And TMP pulp, stronger than groundwood pulps, allows a lower finish in reinforcing chemical pulp for newsprint and magazine papers. And mechanical pulp, good strange properties, lower glass transitions, temperature of lignin, so easier liberations of the fibers in subsequent refining.
So there are three other kinds of pulping process: the secondary fiber pulping, dissolving kraft and sulfite pulping, and also non-wood pulping. So in the secondary fiber pulping process, nearly 50% of the fiber raw material for paper making is based on recycled fiber, and recycled paper or paperboard is rewetted and reduced to pulp, principally by mechanical means. And because the fibers in recycled paper and paperboard have been fully dried and rewetted, they have different physical properties than virgin wood pulp fibers. And then there's the dissolving kraft and sulfite pulping, which is used to produce highly bleached and purified wood pulp, and it is suitable for conversion into products such as rayon, viscose, acetate, and cellophane. And then there's the non-wood pulping process. So non-wood fiber is derived from agricultural fibers such as straw and plant fibers such as bamboo and bagasse. And non-wood pulping make up about 6% of the total fiber supply for papermaking. And non-wood pulping plants are normally small, typically producing less than 100,000 tons per year of pulp. And non-wood plants normally contain higher amount of silica than wood. Next is the pulp washing process. So the main purpose of pulp washing is to obtain pulp that is free from unwanted soluble, and it is carried out with the minimum amount of wash water in order to conserve freshwater resources. And efficient washing is very important because it maximizes the return of cooking liquor to chemical recovery and to minimize carryover of cooking liquor into the bleach plant. And then the most common washing technology is the rotary vacuum washing, which is carried out sequentially in 2, 3, or 4 washing units. So in the pulp washing process, after pulp production, pulp is processed to remove impurities such as uncooked chips and recycles and residual cooking liquor via the pulp washing process. And residual spent cooking liquor from chemical pulping is washed from the pulp using pulp washers, which is called brown stock washers for kraft and red stock washers for sulfite. And the objectives of brown stock washing is to remove the maximum amount of liquor dissolved solids from the pulp while using as little wash water as possible. And the dissolved solids left in the pulp after washing will interfere with later bleaching and paper making and will increase costs for this process. Benefits of pulp washing. So the first one is minimizing the chemical loss from cooking liquor cycle, and then maximizing recovery of organic substances for further processing or incineration, and then to reduce the environmental impact of fiber line operations, and then limiting the carryover between process and stages, and then maximizing the reuse of chemicals and the energy conservation within a single bleaching stage. And the last one is to obtain a clean final pulp product. Next is pulp screening and cleaning process. So pulp screening and cleaning is done to remove oversized and unwanted particles from good papermaking fibers so that the screened pulp is more suitable for the paper or board products in which it will be used. And the main purpose of fine screening is to remove sheaves. So sheaves are small fiber bundles that have not been separated by chemical pulping or material action. And then there's the debris. Debris is the name for sheaves, chop, and any other material that would have any sort of bad effect on the paper making process on the properties of the paper produced.
Bleaching. Bleaching is done to enhance the brightness of the pulp so that it can be used in high purity papers products like printing grades and tissue paper where yellowing is not desired. And its method of chemically altering pulp to make it brighter. It produces wider, brighter, softer, and more absorbent papers than unbleached pulps. A factor that can affect bleaching is the amount of lignin in pulp affect bleaching. High lignin pulp are difficult to bleach completely and require a lot of chemicals. However, the effect is not permanent and excessive bleaching can reduce pulp productions by destroying fibers.
Stock preparation and paper making. The objective of fiber stock preparation system is to modify the different ingoing raw material in such a way that the finished stock finally supplied to the paper machine suits the requirements of the paper machine and of the quality demands put on the produced paper or board. Stock preparations consists of several process steps. Table 2.3. So this is the table 2.3 unit processes in stock preparation. These systems differ considerably depending on the raw stocks used and on the quality of furnish required. For instance, in case of pulp being pumped direct from the pulp mill, dissolution and deflating stage are omitted. The operations are practiced in mass air depression, refining a material and blending of fiber and additive. A number of new concepts have been introduced by Caldan Lamort with regard to virgin pulp stock preparation. Pulpers are used to disperse drop into the water to form a sludge or a slurry. The stocks in pulper is accelerated and decelerated repeatedly, and hydrodynamic shear forces are produced by the velocity gradients. The resulting force serves to loose fibers and reduce any flux into individual fibers. The actual papermaking process consists of two primary processes. The first one, wet end operation. In wet end operations, the cleans and bleach pulp is formed into the wet paper sheets. The second, dry end operations. In the dry end operations, the wet sheets are dry and for this surface treatment are applied to the paper. Figure 2.4 shows the schematic of four dryer paper machines. The foaming section of four dryer consists of what is called the wet end of the machines. This section consists of head box, the foaming ward, foil suction box, coach roller, brace roller, and then roller. Pulp is pumped from the machine's box through the screens and cleans to the head box. The purpose of head box is to deliver a uniform slurry to the forming wire. These are several different designs, but all incorporate a method to induce turbulence deflocculations while preventing cross current, which would inhibit the uniformity of the salts. The simplest design is the gravity-fed heatbox. It uses height or weight lever difference to force the pulp through several bubbles and through a perforated rotating cylinder before following through the apron and slice. Maybe that's all from us. Thanks a lot for your